We've got an inductive proof here, and we've got an exclamation mark and also an inequality. So we're going to start off with our first integer value, which is n equals 4, and we're going to say that 4 factorial is greater than or equal to 2 to the power of 4. Let's just see, 4 factorial is 24, and that is greater than 16. Now I'm going to assume that n equals k is correct, or is true rather. And this particular line, which is k factorial is greater than or equal to 2k, I'm going to use in my inductive line where I let n equal k plus 1. Put in a true here, or else I don't get the mark. Right, k plus 1. Now, before I start doing this, where do I want to get to at the end? I want to replace that n with k plus 1. I want to do some algebra and end up with this being 2k plus 1. So what I know is that k plus 1 factorial, that equals k plus 1 and k factorial. So I'm going to write that as k plus 1 k factorial is greater than k plus 1, and this is where I'm going to use this line here. K factorial is greater than 2k, so that k factorial is definitely greater than 2k. Now this side here, that's k plus 1, no problem. And that's, I'm going to just rewrite it again like that, because that's what I've got in my final line. Now I've got the 2k, and this is 2 to the power of 1, which is 2. Now this k plus 1 here, I know that k plus 1, that's greater than 2. Because k is an integer bigger than 4, so this has to be, even the smallest value is 5, and that's bigger than 2. So I can replace this k plus 1 with a 2. And of course, 2 to the 2k is exactly the same as this line here. So this has done the proof with the inductive part. So I've just write my final line. Proof holds for n equals k plus 1, holds for all n.